Hi guys, time for the last video of Chapter 4. I know you are super excited about that, and let me tell you, making all these videos and listening to my crazy voice has, I think, made me glad that we're at the end of the chapter. But hopefully you've learned something along the way, and hopefully these videos are something you can go back and look at again. The last section that we're going to talk about is triangles and coordinate proof. And in the proof packet that you had last class, you had to do a little coordinate proof in those. So you got kind of a taste of what that's like. What coordinate proofs are proofs that are done on graph paper. All right, the triangles are on graph paper, and you have to prove the triangles are congruent based on them having ordered pairs and plotted on a graph. So you might still use side angle side. You might still use side side side, angle side angle, or angle angle side. Any of them, HL theorem, any of those might be used still to prove congruent triangles, but it's done kind of in a little bit of a different way. So we're going to go through this and talk about each one of these examples. Hopefully you were able to copy these down. I put the pre-notes pages or pre-video notes on my website so that you can just open those up and copy those. So if you haven't seen them yet, you might want to stop the video and go back and copy these down, because you can see that I already have my examples written down, and you can too if you want to pause the video and go back and do that. Alright, so the first example is this: a right triangle has legs 5 units and 12 units. Place the triangle in the coordinate plane and find the length of the hypotenuse. So what we're going to do is we're just going to draw an axis. Alright, I like to keep my pictures first quadrant only, because that way everything's positive. So probably important to go ahead and put the little y on there and the x on there, so that way you can have, it needs to look a lot like an algebra problem. Go ahead and put your axis. It's just the way we do it when we make graphs. So we want a right triangle has legs 5 units and 12 units. So 1, 2, 3, 4, 5. I'm just going to go straight from the origin and count over 5, and then I'm going to count up 12. Now, it doesn't look like I have quite enough room to go up 12, so I think what I'm going to do is count by 2s. So we'll have 2, 4, 6, 8, 10, and 12. And when you do that, when you decide to change the axis like that, you should definitely number your axis, so that way the person who is grading it or looking at your graph can tell what you counted by. Alright, so I'm going to grab a straight edge and draw this. Here's my 12 units. I'm going to draw this right triangle in here. And that's pretty much it. A right triangle has legs 5 units and 12 units. Place the triangle in the coordinate plane and find the length of the hypotenuse. So we want to find out how long this is. So this point right here would be at, that would be at 5, 0 over 5 up 0. This point right here is going to be at 0, 12. And so now we're probably just to find the length of this, we're going to use the distance formula. Remember, the distance formula is equal to x2 minus x1 squared plus y2 minus y1 squared. We've done that before, so that should be review. So we'll go ahead and plug our numbers in here. x2 minus x1 is going to be 5 minus 0 squared plus 0 minus 12 squared. So this is 5 squared plus negative 12 squared, which is going to be 25 plus 144. So it looks like we have a grand total of 169, and of course the square root of that is 13. So the distance of this hypotenuse is 13 units. Alright? So that's how we are going to find distance on a coordinate plane. We're going to use the distance formula. So if I were going to prove two triangles were congruent based on side, side, side maybe, I would go and I would literally calculate the distance of each side to show that they match for each of the triangles. So anyway, we'll get to that again later. The next example, it says in the diagram, triangle MLO is congruent to triangle KLO. So that is MLO, that's this triangle, is congruent to KLO, this triangle. We know they are congruent. Find the coordinates of point L. Well, since we know these triangles are congruent, we are given that, then we also know that line segment LM has to be congruent to line segment LK. Alright, that's just a little CPCTC. And so if we want to find the coordinates of this, then it looks like that's probably going to be the midpoint of that line. Alright, it's halfway in the middle. So to find the coordinates, in other words, find out the x and the y value, we're going to calculate the midpoint of this line. If you remember right, to calculate midpoint, the formula for the x value is add the x's together, divide by 2, and then add the y's together and divide by 2. So if we add the x's together, it's going to be 160 plus 0 divided by 2, and the y's are going to be 0 plus 160 divided by 2. So this is going to be 160 divided by 2 is 80. And the same thing here, we got 80 again. So the ordered pair, or where L is 80, 80. Alright, and that would be the answer, so we'd probably circle it, or I'll just highlight it here to make it stand out. Alright, so it just kind of depends on what you're asked and as to what kind of math you're going to use. Like I said, since we're looking for the ordered pair of that, we're just going to use the midpoint formula. So in this problem we use distance, and in this problem we use the midpoint formula. Alright, now we're going to turn the page and we're going to do some coordinate proofs on plain white paper. And the reason I put them on plain white paper is because you don't know exactly what the coordinates are here. We just have to call this HK. And basically the way I got that was we're going to go to the left a distance of H and up a distance of K. And so that's why this would be at the point HK. So it could be over 5 up 3, over 2 up 6. I mean, it could be anything, we just don't know. But we want to find the length of OC. So we're going to find the distance, and remember, O is at the origin, so it is safe to say that the coordinates of the origin is 0, 0. So if we want to find the length of OC, there's several ways we can do it, but probably the distance formula is going to be the way to go. So let's write the distance formula out. Alright, now we're going to subtract the x's, which is going to be h minus 0 squared plus, and the k here, k minus 0 squared. So h minus 0 squared is h squared plus k squared, and that's about as far as we can go. So that's the length of OC. Alright, that's how long OC is. So I'm going to highlight that, or you can circle it, either one. So you can see that when we don't know what the numbers are, then the answers that we come up with are going to be in terms of variables, like this is in terms of h and k. Alright, so the next problem. You have looks like a parallelogram here. You can see that this is at 0, 0. We've got this at some random point MK. This is at a random point H0 over H up 0. And then to find this point, you're going to go over M, and then you're going to go over amount of H. So that's this point up here at the top, and then of course it's going to be K. If these are both on the same line, then their Y's should be the same. So since this one over here was K, this one would have to be K also. Alright, so you're given the coordinates of the figure. You're going to prove that OTU, that's this triangle, is congruent to triangle UVO. So UVO. Alright, so let's go with our statements and our reasons. Alright, first of all, we're given the coordinates, so you can write that down. Coordinates of figure OTUV, and that's given. Alright, then we just start proving what we know. First of all, we know, remember this is O. I guess I should put that on the drawing here. This is O. So we know that OU is congruent to itself. Honestly, we don't need to do anything more with that, because reflexive property is reflexive property. It doesn't matter whether it's on a graph piece of paper or on a regular piece of paper. So that's reflexive. Now, so that's this angle, or I'm sorry, this side length right there. Alright, now if we want to do this by side, and honestly I don't know any other way, we're basically just going to have to measure how long these pieces are. Okay, and so this proof isn't typically going to look exactly like our usual proof. We may have to go off on a few tangents here. So I'm going to have to figure the distance of OV. So OV from here to here, this triangle, that is going to be a distance of H, because I can see by the ordered pair. Okay, and you don't really need to even write your reasons over here. You can say distance formula if you want. Okay, but we don't really need to. It's a horizontal line, so we can actually just count that, and so we didn't really need the distance formula. Distance formula is used mainly when you have diagonal lines and you can't physically count it, because you can literally subtract these two numbers and find the horizontal line. Alright, now we do need to find the distance of TU. So again, since it's horizontal, all I have to do is take this M plus H and subtract the M here. So M plus H, subtract this M, and that is going to be H. Okay, again, that's the distance formula. So what I've shown here is that OV is congruent to TU. Alright, I've proven that. They're both equal to H. So this line segment is congruent to this line segment. So now all I have to do is prove this one is congruent to this one, and now those are diagonals. So since they're slanted, I'm going to actually have to use the distance formula on those. Alright, so let's use the distance formula. I'm going to do this. This is the distance of OT. The distance formula is the square root of x2 minus x1. So that's going to be m minus 0 squared plus k minus 0 squared. So if I simplify that, I'm going to have m squared plus k squared. Alright, distance formula. Matter of fact, we can just put distance formula there. Alright, so then on step 5, we're going to do, I can even write on this so that I can see what I have here. This is m squared plus k squared. I could just write it right on that line segment right there. Now I'm going to find the distance of this line, which is VU. X2, let's put it down a little bit so you can see this. X2 minus X1. So X2 is m plus H minus X1, which is H, squared, plus k minus 0 squared. Those are my y's. So if I simplify this, do you see those h's are going to cancel out, so all you have left is m. I'm going to have to continue on over here. So I've got m squared plus k squared. Alright, so this is going to be equal to m squared plus k squared. Again, distance formula. So the two triangles are congruent by side, side, side. So if I wanted to finish this out, number 6, triangle OTU is congruent to triangle UVO by the side, side, side postulate. And sorry, I ran out of room there, but hopefully that will help a little bit. Alright, now there's a lot of things that you can use for coordinate proofs to prove. One thing that I do want to mention, and I'll go back real quick here and talk about slope, because sometimes you might like to use angle, side, angle, and I just need a little piece of graph paper here so I can prove. If I want to prove that two lines are perpendicular to each other, so this one has a slope of 2 and 1, 2, 3, 4, 5. 2 by 5. So this has a slope of negative 2/5 because it's going up from left to right. In order to prove that I have a right angle here, I just need to prove that my other line has a slope of positive 5/2. So I might start here and go up 1, 2, 3, 4, 5 over 1, 2. And if I draw that line, probably should have used a straight edge there, would have hit better, then for sure I know I have a right angle. So you can prove right angles by using slope. And you had to do that on the proof packet. So we'll probably talk about that a little bit in class. But I wanted to make sure that you just kind of made a mental note of that. If you have to prove angles, that's really the only way we have right now to show that angles are congruent. So honestly, if they're not right triangles, then you don't have to worry about any angles. You'll always use side, side, side. That's the only time you'll have to prove right angles. So you might want to think about slope and the flipping opposite, because if they're flipping opposites, then you for sure have right angles, and that might help you. Anyway, hope that helps. We'll see you in class.